So, hello students. In the last lecture, we have discussed about the H parameter model of transistor, that is hybrid parameter model of transistor, right? So, in this lecture, we will now further discuss the various quantities that you are required to calculate in the numericals, like voltage gain, like current gain, like input impedance, like output admittance, right? So this is the H parameter model of a transistor. I have already discussed this, how to make this H parameter model, right? So Vi is the input voltage, Vi is the input voltage, I suffix I is the input current, Vo is the output voltage and Io is the output current, right? So this is the ground terminal, that is common terminal, right? You know that ground terminal is taken as common terminal, right? Suppose if it is a common emitter, that means this ground terminal will be emitter, right? So so this is the H parameter model of a transistor, right? So in this H parameter model of the transistor, we will now calculate the input impedance. See here, so like I told you that the H parameters are related like this. In the matrix form you can write like this: input voltage Vi, output current I0, or you can say IO. These two are related with input current II and output voltage VO by the H parameter model like this. So HI, HR, HF, HO, these are the basically H parameters, right? So these H parameters will be given to you in the numericals: HI, HR, HF, HO, right? So now when you open this matrix, you will get equation number 1, that is Vi is equal to HIII plus HR into VO, right? Similarly, second equation you will get when you open this matrix, you will get IO is equal to HFII plus HOVO, right? This is the equation number 2. So I am simply writing these two equations by simply opening this matrix, right? Now my aim is to calculate this Zi, that is the input impedance, right? Input impedance I want to calculate now, right? So what I will do, first of all, I will divide the equation number 2. I will divide this equation number 2, that means the second equation, by II, that is input current II, right? So when you divide this by II, you will get IO by II, right? Here you will get HFII divided by II, that means II and II get cancelled, right? And here you will get HOVO by II, right? So simply divide equation number 2 by II, input current II, right? So IO by II is equal to HF plus here in place of VO, output voltage VO, what you can write, see here, the output current in this load resistance RL is flowing like this. That means this is the direction of output current in this load current. That means current is flowing from here to here. That means in the direction of current there is a voltage drop. That means later sign will be negative, so this sign is negative here. So what is the polarity of output voltage here? Plus upside, negative downside. That means VO is equal to minus of IORL, right? Because here it is minus plus and here it is plus minus. So VO is equal to minus IORL. That is the voltage drop in this load resistance, right? So in place of VO you will write minus IORL. Output voltage VO is equal to minus IORL, right? You simply put VO is equal to minus IORL here and you will get HO bracket minus IORL divided by II, right? So now IO by II with negative sign you will get in the right hand side, and 1 IO by II you will get in the left hand side. So take both in the left hand side and take these common. IO by II, when you take common, you will get 1 plus HORL, right? 1 plus HORL here is equal to HF. right hand side you will get HF only, right? So that means IO by II, what is this? This is a ratio of two currents, output current IO divided by input current II. This is the ratio of current, or you can say current gain. It is denoted by A, capital A suffix I. That's the standard notation. So you can note down IO by II is basically current gain, that is represented by A suffix I, AI, and it is equal to HF divided by 1 plus HORL, right? HF divided by 1 plus HORL, right? So HF is the forward. HF and HO, they are the H parameters, right? HF and HO are the forward. HF and HO are the H parameters, right? They will be given to you in numerical. RL is a load resistance, right? It will also be given to you in the numerical. So once you have given these values, you have to simply calculate current gain AI by simply putting these values HF, HO, RL, and you will get current gain, right? Right. So here now again I'm going to do some manipulation. That means divide equation 1 by II. This is the equation number 1. I have to divide this equation 1 by II. Once you divide this equation 1 by II, input current II, you will get VI by II. Here you will get HI, II by II. That means II get cancelled. So first term become HI plus HR VO by II, right? Second term will be HR VO by II. What I did? Simply I divided equation number 1 by II. Then I will get VI, input voltage VI divided by input current II. VI by II is equal to HI plus HR VO by II, right? Now again you put VO is equal to minus I naught IORL, minus IORL. So here in place of VO put minus IORL. So you will get VI by II, that will be equal to HI plus HR, bracket में minus IORL divided by II. So VI by II is nothing but ZI, that is the input impedance. Input voltage divided by input current, VI by II is nothing but the input impedance ZI, is equal to HI plus HR RL, and IO by II, I told you this is nothing but the current gain. So in place of IO by II you can put AI, right? So here is one, here you will see one negative sign, so put a negative side here, right? So finally you will get ZI is equal to HI minus AI HR RL, right? HI minus AI HR RL. So once you put AI is equal to HF divided by 1 plus HORL, what will you get? You will get input impedance ZI is equal to HI minus HF HR RL divided by 1 plus HORL. This is the input impedance, right? So HI, HF, HR, HO and load resistance RL. All these will be given to you in the numerical. Simply put all these values in this formula and you can calculate input impedance ZI, right? So what is ZI? It is nothing but HI minus HF HR RL divided by 1 plus HORL, right? Okay. So now let us go further.